A number of you know me from the past. This time I'm not going to try to sell you anything, so you can put away the guns. RDL is an initiative that comes out of NLnetLabs. Benno Overeinde is the project lead. And it is currently the core part of something called NGRIT, which is the next generation routing information toolset. NLnetLabs is a not-for-profit which has as a purpose to do good things with the internet. And they have been focusing much on the improving stability and security and so on. RDL is one aspect of a multi-pronged approach. On other aspects, we'll focus on authentication and similar things. And many of you may know that NLnetLabs has previously done much work with secure DNS. Reasoning behind RDL is if you look at the global ISP industry, and just the industry itself, not customers and so on and so forth, it is huge. We are talking about dozens of millions of dollars per hour. You can sort of do a number of metrics, you get different numbers, but we are talking about something that's huge. It also means a lot of people's livelihoods depend on it, and that's the general rationale also behind NLnetLabs' interest in improving stability and security in the internet. As somebody said, there's 1 million app developers, but there's only a handful of people that revisit core technologies, just like DHCP earlier today. Router configuration is inherently very low level. It's on the level of assembler, if you compare it to a programming language. A large number of only model-rated related detail. Current router configurations run into the hundreds of thousands of lines of machine-generated code. And there's probably a lot of cargo cult code in there, which is just included just to be sure. That impacts routing stability. Routers are heavily loaded, and maintenance is a bit troublesome. There are very few or any really good verification tools. You don't have much in the way of automated verification. And there's limited scope also for intra-AS routing management. Now somebody, of course, say RPSL, and RPSL was a very good early effort, but it's definitely showing its age. And RDL was born out of a need to replace RPSL with something more functional. The general idea is a high-level routing documentation language, not focusing on the details and mechanics of route filtering, but documenting your BGP routing policy and your BGP topology. And to that effect, it comes up with having two purposes, really. One is the architecture-independent generation of BGP configuration, much like you will compile C to 68K or x86 or to ARM or any other architecture. So RDL will compile to Cisco, Juniper, Bird, or other platforms as needed. The other one is the RPSL part, which is, again, to describe and publicize routing policies. Yeah, I mean, I assume, who doesn't know what RPSL is? Everybody knows what RPSL is. Excellent, okay. You also know that it's a bit over-engineered, a bit cumbersome, a bit heavy on detail, and you very often end up just beating up on route filters. RDL is not the next generation. We'll reuse some objects, and one of the guys in the working group has found a hack, if they think, so that we can actually reuse the mechanisms for the RIPE database. So it's very easy to actually use RDL instead of RPSL. But more importantly, RDL describes the BGP topology of a complete autonomous system. You're not in RPSL. You're very much focused on on this router, on that interface, use this filter, unless and so and otherwise, etc. We describe the entire BGP topology, internal and external BGP. Internal is actually completely automatic, and we specify policies for the whole network. And that means that you're completely moved above the fiddling with the route filter mechanics and routers and so on and so forth. We'll, of course, get to it later. What is a policy? People talk very much about policy, but often they talk about enforcement actions. A policy is thieves will be prosecuted. That's a universally applicable policy that applies all throughout the land, if you wish. A particular action is arrest Parker. Parker is before he was reformed. And current policy tools, they talk about policy, but they are very much talking about enforcement actions, how to actually implement the thing rather than what the policy should be. And the whole thing quickly degenerates into what I call root filter mechanics. And there's no, I don't mean to be disrespectful, but that is the current state of affairs. And it's not very good. We're programming in assembler, effectively. Now, what RDL does is add a third dimension to the whole thing, which is namely where it applies. That's what kind of makes the difference between an enforcement action and a proper policy. We've got to say, think about this, if you look at legislation for speed limits, where does the law apply? The law applies on public roads throughout the land. It doesn't apply on private roads or racetracks. It applies on public roads. When does it apply? That's when you exceed the stated speed limit, and what happens? You get clobbered. Currently, the current tools and methodologies really miss that third element. And that, together with the topology description, which RDL enables us to do, means that we get something which is much, much simpler to work with. We'll get to it. For instance, and we're not getting to the code quite yet, sorry. For instance, you have a policy that says, my AS will not announce bogons. Where, that's the new thing, it's all peerings with foreign ASs. Now, if you can find a way, and that's what we're doing, of putting that into a single statement, you can have that turn into a filter here, which is applied automatically in all configurations for all routers in your system. You don't look at individual routers anymore. And that's what really is the key with RDL. Yeah, the rest is sort of, these are typical filters, as we know. The language itself was designed specifically for the purpose of describing B2B topologies. The whole project I got involved in December, but RDL in its current incarnation wasn't really until February, so it's still very early days. It's a very free-form, curly brace, blah, blah. It looks a bit like PHP or something else. It's very intuitive. It's pleasant to look at. It's easy to work with. And it avoids a lot of the detail that you know from our PSL. Whoops. And if you, for people that are language aficionados, you'll see many elements from different languages that it has borrowed from quite disrespectfully. No declarations, dynamically typed, and a minimum of declarations. Now, B2B topology is described by way of three core objects. The zone is the one that many people find a bit difficult to get to grips with. A zone is the biggest enclosing element. So you can think about it a bit like a directory in a file system. It's a group where you will group together smaller objects that have a lot in common. A typical multinational network, like one we're working with, is Hibernia, formerly called Atrato. They will principally divide into three major zones, which is United States, Europe, and Asia Pacific. Inside zones, you can have other zones, and they will typically divide into one zone for each country. And inside each country, they divide into cities. But it doesn't have to be like that. It's important, because I've just shown this to people, and they say, but my network doesn't look like that. Well, that's fine. The zone map that you create should describe your network and how your policies apply. It isn't so that your network has to be forced into any particular model of a network as described by RDL. You decide what works for you. And some networks may have only one zone, maybe two. I don't know. Each object, yeah, routers, well, we know what they are. And inside each zone, you'll typically have multiple routers, but you may have just one. So there's no problem with that. And inside routers, we have peers, and that's one peer per external peering. You don't configure internal peers, that's done automatically. And yeah, each object has attributes, and to make it easy, attributes may be inherited from lexical scope. If you're familiar with programming languages like, say, Pascal or the GNU-C extension that has nested procedures, you have kind of pseudo-global variables that you can see from nested procedures. Likewise, we can inherit everything that we can see from a nested object. So, for instance, you will typically specify the system's AS number in the topmost zone, which describes the whole network, even though the AS number is not relevant for that. The AS number will be seen and inherited by routers further way down automatically. So you only specify that once. Here, example. This is what it looks like. This is sort of an embryonic declaration for what Havonia would look like. We have a constructor. The 3-4 major objects, they have constructors because the syntax doesn't supply enough information to figure out what it should be. That doesn't matter. We string things together with dots. So you basically have an object and you specify further details and they're sort of automatically sucked into the object. Set an attribute here which is AS number. Again, as I mentioned, that doesn't mean anything for the zone, but it will be inherited by this router. Here are examples of further zones, and here we have a router. We set the address for the router like so, and we create a peer. And to be neutral, I've used ripe. Yeah, RDL, it tries to be helpful so that if it can deduce from the list of details here what is missing in this one, it will see that this is the address of the peer and this is the AS number of the peer. It's so that the number of mandatory attributes is the minimum that's required for BGP to come up. And so this is the minimum. A router needs an address, a peer needs a remote address and an AS number, and the router needs an AS number, which it gets from the top here. Now further zone here is United States and Asia Pacific. Is that, anybody who's got any immediate questions to that? Fire away, shout.
Just a simple one. What syntax is the dots there?
The dot is to string bits together. So if you do 1.2.3.4, sorry, I'm thinking IP. If you have, say, a list with elements 1 and 2, and you dot another list 3 and 4 onto it, you get a list which is 1, 2, 3, 4. So it's a bit like plus, if you wish. It's basically, it starts with this, and you just dot things onto it, and they get absorbed and merged in the most logical fashion. So it's very easy to construct things. So earlier, Node.js, same story kind of thing. You could have blocks, and you just tag other blocks onto them and construct things.
Why don't you use XML? Sorry, can people wait for a microphone?
No, so we're running a bit short. If shout, I can repeat it.
Why not to use XML in this scenario?
Because this would be horrendous in XML. Absolutely horrendous and unreadable. You have to ask, what were they smoking or drinking? So the whole purpose here is, I mean, for anybody into languages, if you go and look for programming languages or any kind of language, there are hundreds, if not thousands of them. So a new language that's purpose-made, there's no harm in that. There's no point in trying to beat some existing language into something it wasn't designed for. In particular, something as important as this. It's very simple to use. The syntax is really simple. Strictly speaking, it's all lists of lists of lists, technically. But the layout we choose and some subtle choices here means that it actually looks very pleasant. We've had good feedback on it. I wouldn't want to do this in XML. So, what's in the zone? As I talked, they are, well, we sort of covered this already. The important thing is to repeat, they should be chosen to reflect the reality of your network. Your network isn't supposed to be squeezed into some particular format. You decided to be, it's all about BGP topology, how policies are aggregated, as for instance, the case here being that many people will have different policies, announcement policies for US and Europe. And the zone map, the aggregated map of zones, kind of identifies reference points where you can hang policies onto, and we'll see that later. Here's a policy example, the no bogons. This is again what it would look like. We assume we have a bogon list, and here we've reused the syntax from RPSL. And you create a new policy. Where does it apply? It applies on export conditions where the AS number of the peer is different from the AS number of the router that the peer sits inside. That's kind of the definition of an external peering, unless you're running P2P configurations, but that's sort of a separate issue. What if the NLnetLabs prefix matches bogons? Don't get hung up in the syntax. I used AN here to kind of indicate a match. What you want is, of course, set membership, but that, then we'd have to use the euro symbol or something like that. And what you do, reject. Now that policy applies throughout the network. You never put it into a router configuration anywhere, because you have fully defined what the policy is, where it applies, and what it should be. You only specify that once for your entire autonomy. You can have 1,000 routers, it's still there. It doesn't change. Just as you can do with other things, policies can be dotted together so that you would, for instance, construct more advanced policies. By creating a new policy, you would dot on no bogons, and you would dot on one called customer routes and one called this customer special, if you wish. The syntax is experimental, because we haven't gone that far, really. But it'll be something like that. That's what we expect. Here's a slightly unusual example. Again, Hibernia. They have this situation, which we'll get to. We indicate here we have a router which is flagged as a route reflector. That's actually superfluous. We specify here that IBGP is an attribute which defaults to full mesh. We have full mesh, local mesh, which means that it will mesh inside the zone and down, and route reflectors, a list of route reflectors, and we can put them together like this. So inside the EU zone, you will use R1 as a route reflector for that, and you'll otherwise mesh fully inside the EU zone. Slightly unusual setup, but what they do is they use the route reflector, they have the two, and they're completely out of band. They're sitting, I don't know, it could be the Azores. And here inside the US zone, you have the same one. And they use route reflectors to transport routes between US and EU. Now here's the kind of unusual thing. They deprioritize all EU routes in the US. And the way they do that is they set a local preference when they import routes into the US from EU announcements. And RDL can do that too, where we have an import situation where the peer.zone is inside US, less than or equal, we consider that to be inside, and the peer.remote.zone is inside EU, when always what equal local preference equal 90. All done. Only specify that once. Route reflectors, they're transparent to the system because they are just that, route reflectors. So the system will correctly detect that the peer and the remote are inside US and EU, irrespective of where the route reflectors are. The route reflectors connect the US and EU, and it's just a conduit. Okay, now, another example. For instance, if they wanted to drop the route reflectors and go to full mesh for the whole US-EU setup, you require only a few edits. You delete that line, and delete that line. That's all you have to do. Policy is now changed for your entire system, and the system will now build a full mesh between US and EU. That's right. And if you don't get it right, if you delete this one, you'll get an error message from here, because it doesn't know CRR1. And if you delete that one, it'll give you a warning that there's an unused route reflector here. So it's very easy to do major changes. Now, if you imagine that you do this manually, and suppose you miss out an internal peering between two boxes. You'll have two boxes that have 98% of the routing they should have, and a few glimpses. It's going to take ages to find out what goes wrong, and your customers will suffer. Here, With this, it's all done for all the routers with just a couple of keystrokes. So, is it nirvana? We hope so. We hope it's a big step forward in terms of programming network rather than configuring routers. It really is important to think about this as sort of a big step up, a big abstraction, like programming in C instead of in assembler. Any questions? And while you run with the microphone, I should say, if you have any admin questions, if you want to join the working group, open to members. This is Benno at NLnetLabs.nl. If you have any, okay, careful, please.
Sorry, don't laser me.
This is me. Those are my initials, Per Gregers Bilse at BGP Innovations. We all have issues with our parents, but mine had foresight. So, any questions? Yes.
So, hello? Yeah. Hi. So, you first mentioned things like the IRRDB stuff and how people do RPSL type syntax to describe their network to outside. As you probably know, it's pretty much only the ripe area that people do that in, and it's still not universal coverage. It tends to be side projects. Without being rude, I'm probably one of the only 10% of people who actually bother to do it and do it in a decent way. How do you see this actually going out to networks in the world? I mean, how do you encourage people to take it up?
It's a very good point. It's something that has been discussed. The main point is, one, Europe is a big place, and we all like each other a lot, except some people. And if it ends up that it only does something good for the European internet industry, so much the better. It's other people's loss, not ours. The other one is that, of course, it is now 16 years ago I wrote in the AS286, which was my old AS, at the bottom of the RPSL config. Generally, policies are too complex to express in RPSL. This is incomplete. I think it's still there. And I think the complexity with doing things in RPSL, the amount of work you have to put in, means that it's a kind of superfluous exercise because you spend a lot of time and effort and get very little in return, or at least not a lot in return, not compared to the effort you have to put in. Hopefully, we can make it a lot easier. More people will do it.
Just as a side to that, when I look at an RPSL entry, I can, as a human, read it very quickly and find out one line what's going on. With this, I have to have some kind of interpreter doing it for me, unless I'm particularly smart at reading code. Is there going to be some kind of tool that we can use to kind of put information in and get something out? Email.
Send an email.
Grand.
It's very much, it's important to understand this is entirely open. NLnetLabs is a not-for-profit, and this is going to be released under BSD. Anybody who's got some good ideas, please come forward. We can use more people. But it's a sort of, it's an initial point. I'll take note. Yes, Mike?
Hi.
Not Mike. Okay, microphone.
Am I to interpret that this is very much pre-standard? You've got no vendor buy-in on this yet as a direct interpreter on any vendor equipment. This is a way of structuring your AS that you would then compile into something you'd put on your router, or are you...
in practice, what I'm working on is a compiler that reads RDL and produces router configuration or BGP configuration.
Okay.
So we don't really need vendor buy-in, but if somebody wants to put this on their box in a way, fine. It'll be under BSD license, so it's fully available for commercial use as well.
Okay, thank you.
Okay, Mike.
Hello there, Mike Hughes, but I'm proxy for Adrian Farrell, who's just asked on Twitter, why RDL and not Yang? What's wrong with Yang?
I have no idea.
You don't know? Okay, fine.
No. As I said, the project was born out of user input from the RIPE community. And I'm not sure Yang doesn't ring any bells with me.
Yeah, Yang. So basically defining this as Yang models that didn't come in the spec from NLnetLabs. You
this-
don't know why.
so-
You've been told to just go and write
Sorry,
this.
does it look like Yang?
No.
Oh, so what is Yang? Yank?
Yang.
Yang. What is Yang?
Y-A-N-G. Yang.
Yeah, what is that?
So it's basically a network definition language. You build a Yang model that says
Okay.
this is how
no.
a network's going to look, and it's like
Okay, nobody brought this to my attention. Is Yang better than this?
different.
Well, the
Yankees.
ITF liked this one as well, because I did a presentation at the IPG meeting and we had very good feedback. Now, nobody's hung up on anything here. That's really important to understand. If somebody has a better source language for doing what we're trying to do, fine. I'll rewrite the front compiler is just Flex and Python.
I'm not part of a religion. I saw
okay.
the question fly past on the UK.
Yeah, so it's very,
Twitter
very
again,
good.
so I thought I'd ask
Anything
it.
goes.
Okay. Thanks
Okay.
very much, Per.
Okay, welcome.